Okay, so let's do some derivatives with logarithms. So first off, the simple derivative of just ln x is just 1 over x. And let's prove it, and we proved it here. So let's say we have y equals ln x. Using logarithm rules, we can say that e to the y is equal to x because ln is really log base e. So you can just say e to the y is equal to x. And now if we just find the derivative of both sides, implicit differentiation, the derivative of e to the y is just going to be dy dx times e to the y. And then now we want to isolate dy dx, so we're going to divide by e to the y on both sides. So now we get dy over dx equals 1 over e to the y. Now we can substitute this as x because here we already said x equals e to the y. So if we just substitute e to the y as x, we have our answer, dy over dx equals 1 over x. So that's why the derivative of ln x is just 1 over x. And let's do some problems with these. Okay, so the first question we have is find the derivative of ln of 2x plus 2. So here we can use chain rule. So we have the inner function as 2x plus 2 and the outer function as ln x. So let's say a equals 2x plus 2, y equals ln a, and y prime, we already proved it, is just going to be 1 over a. Now a prime is just going to be simple power rule, so a prime equals 2. So now, chain rule, we have to do y prime multiplied by a prime. So it's just going to be 1 over, and we said a is 2x plus 2, 2x plus 2, multiplied by 2. And since 2 is in the numerator, we can cancel or simplify in the denominator. So this can go, and this can go. So the final answer is just 1 over x plus 1. Okay, question 2 we have, find the derivative of ln tan x. So again, we can use chain rule. So let's say the inner function is tan x. And now the outer function is ln a. So y equals ln a. Now the derivative of ln a is just 1 over a. So y prime equals 1 over a. Now a, or the derivative of a prime, is just, the derivative of tan x is just secant squared x. And now let's multiply them together. So 1 over tan x times secant squared x. So you could leave your answer just as secant squared x over tan x, but you can still simplify further. So secant squared x is the same thing as 1 over cosine squared x. So 1 over cosine squared x, all divided by, tan is just sine over cosine. Sine over cosine x. So we can cancel 1 cosine in this fraction. And now we're going to have 1 over, we can just move it up here, 1 over sine x times cosine x. And this is the same thing, 1 over sine x is the same thing as cosecant x, and 1 over cosine x is the same thing as secant x. So we can just replace this and say the final answer is CSCX times secant x. And that's our final answer. Okay, question 3 we have, find the derivative of log base 5 square root x. So the first thing I'm going to do is use the change of base rule. So I can rewrite log base 5 square root x equal to ln square root x over ln 5. Now it doesn't have to be ln. In fact, you can make the base anything you want as long as it's the same in the numerator denominator. You can have log base 5 square root x over log base 5 of 5, or 100 on the top and bottom, 1000. It doesn't matter what the base is as long as they're the same. I like to do ln because it's just the most common one and simple one. Okay, now this square root x is the same thing as x to the power 1 over 2. So we can rewrite this as ln x to the power 1 over 2 divided by 5. And this, we can bring this down using another log rule, 1 over 2 ln x, and then divided by ln 5. Now again, we can bring this 1 over 2 down. So now we can have ln x over 2 ln 5. Now what I'm going to do is separate it so that the denominator of ln x is just 1. So I'm going to do that by just saying ln x over 1 times 1 over 2 ln 5. Now, since 1 over 2 ln 5 is just a constant, there's no variable, this is going to remain the same after we find the derivative of ln x. And obviously, the derivative of ln x is 1 over x. So 1 over x times 1 over, 1 over x times 2 ln 5. Now we just multiply the two together and we get the final answer as 1 over 2x ln 5. And that's the final answer. Okay, question 4, we have an interesting one. Find the derivative of ln x. But we can use the exact same thing we've been doing before. So let's use chain rule. A equals ln x, and the outer, which is the inner function, and the outer function is also ln. So y equals ln a, and y prime is just 1 over a. And now the derivative of a, the inner function, is just 1 over x. So a prime equals 1 over x. Now we can just multiply both of them together. So a we said is ln x, so 1 over ln x times a prime, which is 1 over x. So we just multiply both these together and we get the final answer as 1 over x ln x. Okay, question 5 we have, find the derivative of x square root x squared plus 1, all divided by x plus 1 to the power 2 over 3. Now you might be wondering, where's the ln x, or where are the logs? But the thing is, you don't need any logs in the actual function in order to use the rules of logs or using logarithmic differentiation to find the derivative of a function. So here, if you don't know what logarithmic differentiation, you might use chain rule and then product rule and then quotient rule to find it, but that becomes a lot more complicated. So we can use logarithmic differentiation for this function to make it a lot simpler. So first off, I'm going to set this equal to y. So y equals x square root x squared plus 1. So just the exact same function, x plus 1 to the power 2 over 3. Now what I'm going to do is I'm going to multiply both sides by ln. So now I'm going to have ln y equals ln x square root x squared plus 1 divided by x plus 1 to the power 2 over 3. Now, when you have something multiplied by something else inside of a log, you can add them both together. So I'll show you what that looks like. So we can say ln y equals ln, now x is being multiplied by square root x squared plus 1. So we can say ln x plus ln square root x squared plus 1. And then now when we're doing division, we subtract. So we just say minus ln x plus 1 to the power 2 over 3. Now let's simplify a little bit. So ln y equals ln x, we can't do anything for these two, plus, now, x squared plus 1 is to the power 1 over 2, because that's what the square root is. So we can bring that down to the side. So we can say 1 over 2 ln x squared plus 1 minus, and now 2 over 3 is to the power of x plus 1. So we can bring this down as well. So minus 2 over 3 ln x plus 1. Now, let's move over here. So now let's find the derivative of both sides. So the derivative of ln y is 1 over y dy dx because we're differentiating with respect to x. So the derivative of ln y is just 1 over y dy dx. And this is equal to ln x is just 1 over x. And then the derivative of this is just plus. So you can use chain rule, but if you think about it, you don't really have to write everything down. So you can just find the derivative of the inner function, which is 2x. So you can put that on the top and then divide it by the inner function multiplied by the constant. So the constant is 1 over 2. So we have 2 times x squared plus 1. So we can cancel off these 2's and just say x over x squared plus 1. And now minus 2 over 3, we can use the same thing. The derivative of the inner function is just 1, using the power rule, and then divided by the inner function, which is x plus 1, and multiply by the constant. So this 1 actually turns to a 2, and then the denominator we have 3 times the inner function, which is just x plus 1. But we're not done yet because we need to isolate dy dx. So we're gonna multiply everything by y. If we multiply everything by y, this y cancels out. But since we multiply by y, everything on the right side is multiplied by y. So dy dx equals, now y is the same thing as the original function that we said before. So all we have to do is take our derivative and multiply by y. So we have 1 over x plus x over x squared plus 1 minus 2 over 3 times x plus 1. And everything is multiplied by the original function. So x square root x squared plus 1 divided by x plus 1 to the power 2 over 3. And that's the final answer. So let's box this in. Okay, question 6 we have, find the derivative of x to the ln x. So we can use the same strategy as we did for number 5. So let's set this equal to y. Y equals x to the power ln x. And once again, let's multiply both sides by ln. Now we have ln y equals ln x to the power ln x. So you can see that we have ln x is to the power of x. So we can bring this down using our log rules. So we can say ln y equals ln x times ln x. Now this looks a little similar to what we did before, except this time there's an x here. Instead, last time for I think 3 or 4 we had ln of ln x, but this time it's ln x times ln x. So instead of using chain rule, we're going to use product rule. Okay, so first let's find the derivative of this, which is just 1 over y dy dx equals, okay, so let's just write it off to the side here. U equals ln x, v also equals ln x. So that means du equals 1 over x, dv is also 1 over x. And product rule states that vdu plus udv is the derivative. So vdu is ln x over x. And udv is also ln x over x. And then now, if we multiply both of them, or add both of them, we'll just get 1 over y dy dx equals 2 ln x over x. But once again, we're not done because we need to isolate dy dx. So we're gonna multiply both sides by y. So now we get dy dx equals 2 ln x over x times y. And we said that y is the original function, x to the power ln x. So let's just write the final answer here. dy dx equals 2 ln x over x times, and y, we said x to the power ln x, so x to the power ln x. And this is the final answer.